Hello and welcome to another CS200 mini lecture. Today we'll talk about chapter 12.7 through 12.11. Specifically, what we'll address is abstract classes. We'll look at some UML diagrams, is-a versus has-a relationships, and we'll also look at interfaces. So let's get started. In 12.7, we begin with abstract classes. An abstract class is just a class that guides the design of other classes, meaning subclasses, but we can't instantiate it itself as an object. So if we think about grocery item, and then we might have different types of grocery items, maybe one might be perishable, meaning it can go bad, like a tomato or a banana, fruit, maybe dairy products. So generic item, maybe we don't want to implement a generic item. We just want to use it to guide the design of different types of subclasses, meaning fruit or vegetables or dairy products, for example. And then we may have other classes which aren't perishable and don't have an expiration date, such as certain canned goods. Let's take a look at this example. This example shows an abstract class called shape, and then we have a concrete class called circle. And what happens is shape is the abstract class, but it's also the superclass, and circle is the subclass. If I go through this example, we know that a class provides data, right? So we have field members as well as behaviors, which are methods for objects. So because it's declared as abstract, we cannot create an object called shape1 or shape2. We'd get an error if we tried. However, because circle is derived class or a subclass, we can actually create objects based on the circle. So they can have behavior and they can have data that are associated with them. So one example might be, and this is not my subject area, but biological classification. So if you recall from your bio class, you have domain, kingdom, phylum, class, order, family, genus, and species. So they go from very broad to very narrow, meaning we want to create one object that is a grizzly bear. However, if we go to domain, and again, our kingdom might be animals. Okay, so animals is just too broad and too generic for us to implement an animal, but we can implement a grizzly bear or a grizzly bear named Joe, for example. So moving on to 12.8, we've talked about abstract classes, but now we're going to talk about abstract methods. So that's a method that's not implemented in the base class, meaning this superclass or the abstract class, but all derived classes must override the function or the method. A method signature, remember what a signature is. It's basically the list of parameters along with the method name. So that helps define the method's name and its parameters, the arguments it will take. So an abstract class is one that can't be instantiated, just like we saw with the last chapter. And we use the keyword abstract in front of the class definition. So if a class has one or more abstract methods, then the class itself has to be abstract. A concrete class, on the other hand, is just like we saw with the previous example, where a circle was a concrete class, but shape was an abstract class. Here is an example of how it can be defined. Notice the keyword abstract here, and also in the method, there's the keyword abstract. So again, there's lots of examples, but if we want to implement a shape, we're going to get an error. So notice down in our main class, we want to implement a shape, but because it's defined as an abstract class with abstract method, we would get an error when we tried to create this. We tried to allocate memory for it. So if we think about how to define, and I think shapes is a good example here, we can think about a shape, but it's really hard to define specifically. Whereas a circle or a square or a rectangle or a triangle, those can be implemented because we can associate different characteristics or perhaps variables, as well as certain behaviors. So a circle might have a circumference. We can get and set those, so we can use accessor methods for them. And a point might be just a definition of a point of reference on a grid. However, this just illustrates the fact that an abstract method like compute area needs to be in a public abstract class. Okay? So if we have a circle class, we need to override the compute area. And then also the rectangle needs to override it as well. So that compute area that we saw up here, if we have it as defined as an abstract method, we need to make sure we override it in the concrete classes that we create. So this is the test method. So you can see it's our main, and you can see how we implement these different things. I'm not going to go through this specific example in BlueJ. However, you can get the idea of how to implement using what you see here. And you'll get a result much like what you see here. Now we move on to chapter 12.9, is-a versus has-a relationship. So this is kind of important in terms of modeling because we need to consider composition. So has a relationship. So a parent and child, for example, if we implemented those as objects, so a child would have a parent. And so we would say that has a relationship. So for example, if I have a house has a roof, a house has windows, a house has a door, a house has a foundation. Now, there's another way in which we can model it, which is through inheritance. Inheritance means there's certain characteristics that are generic versus concrete. So if we take the same example of mother and child and think of those as objects, now a child has a mother, but both child and mother are people. So that would mean they have that's an is-a relationship. A mansion is a house, for example. But a mansion has doors, a mansion has windows. So if you think through it, this helps identify the is-a versus has-a relationships. And these are important because these help us determine when to do inheritance. So now we move on to Unified Modeling Language, or UML. So BlueJ has kind of a variation of UML. It's not as robust as UML is. So there's a certain notation, and you see here you've got generic item and produce item. And you look at the keys over to the side. So negative means private, a pound or a hash means protected, and a plus means public. And normally you have the name of the class, and then below that you have the field members or the variables. And then below that you have the methods. And you can see here each of those have either a dash, a hash, or a plus sign next to them. So now let's look at chapter 12.10 and explore UML a little bit more. So UML, of course, is used for software design. It's a variation of this is used in lots of different types of software engineering projects. So you will see this probably later on if you take the CS350 course. UML is kind of a standard de facto language. It's one in which if you use it and you're talking to other software engineers, they're familiar with it. So it helps give a visual structure to different types of classes, methods, and data. So a structural diagram looks at the static elements of the software, such as variables and methods. Behavior looks at different types of behavior of the software, such as a flow of an algorithm. And then a class diagram is kind of what we're looking for here, where we can see the classes of a program, the variables and the methods, and whether they're public, protected, or private. So in this participation activity, they show you two different classes, and they show how different member names and variable names show up. So one thing that BlueJ does is it implements UML similar to what we see in this diagram. So we have Circle, which is a subclass or a derived class, and it inherits from Shape. So it's also a derived class that's it's a concrete version of Shape. You can see that Shape it's italicized, which means in UML that means it's an abstract class. And you can see it's got an abstract method called compute area. And Circle, you can see it doesn't have anything italicized, which tells us that those are not abstract methods, and those aren't abstract variables. So if I go to BlueJ, I can see arrows going all over the place. And you can see some of them are hollow and some of them just point like this. So if I go here to pet data and animal data, you can see that pet data is a subclass of animal data. So now let's talk about interfaces. An interface is simply a set of abstract methods that you have to override and define. And this definition, in fact, this chapter in Zybooks is not very good. So I'm going to supplement it in a minute, and we'll talk about it using PowerPoint. Let's go through and see what they have to say. So if we implement an interface, we have to give, instead of saying class, we say interface here. And interfaces are public, and there's a couple of different reasons why we'd use an interface instead of an abstract class. So, and if we want to implement, we would say public class square implements these different interfaces. So the interfaces have been defined, and then we have to override draw and draw ASCII, which if you look up here, are the interface names, and then also you've got these methods in here, draw and draw ASCII. So you have to override them because we can't implement them in the interface themselves. So let me give kind of a supplemental view of interfaces, and this was something that I got from W3 Schools, which I think explains it a lot better. So interface is just another way to achieve some kind of abstraction in Java. And an interface is just a completely abstract class that's used to group related methods. And notice here it says with empty bodies. What we mean by that is there's no body to the actual implementation. So how do abstract classes differ from interfaces? Well, with an abstract class, you have to use the extends keyword. Remember we had shape, which is our abstract class, and we have concrete classes, circle and rectangle. With an interface, we use the implements keyword. Remember, we don't call it a class, we call it an interface. So in this second example over there on the right, you see that shape is our interface and circle and rectangle are what we implement using the implements keyword. So why would we use them, or what do they do? So interfaces can't be used to create objects. So let me go and show you an example here. So here I have created an interface called animal, and notice that these are public, and notice I called it interface. So when I implement this, notice this method doesn't do anything. There's no body to it. That's what we say about having an empty body. So I have animal, and then I have pig. So pig is what's being implemented by the animal interface. So I define class pig implements animal. So then I have, for example, maybe I have a sound and sleep. And all I'm going to do here is just print out, say the pig says wee wee, and then when it sleeps, we just say z. Okay? So in BlueJ, you can see how the arrow goes between pig and animal. And notice here it also gives the interface in angle brackets here. So in UML, it does something similar where you use the double chevrons to implement or to illustrate that it's an interface instead of an abstract class. So here is my main class. And notice what I'm doing here. I'm just basically saying I'm basically creating a pig object. Remember, pig is my concrete class. Then I say my pig sound and my pig sleep. Let's go back and look at pig. And you can see here, I don't have to override it. I just have to basically create a animal sound here, which is the method that in animal I just defined. Okay. So now if I run this, what happens here is I get the output that I would expect. So interface methods don't have a body. Remember what we had there is we just basically defined the signature of the interface. So the body is provided in the implement class. So we had animal as our interface, pig as the implement class. So when we implement the interface, we have to override all its methods. What we mean by that is we need to basically specify every method that was in that interface. And remember, it had two, an animal, and then in the pig, we actually had to define each of those methods. So interface methods are by default abstract and public. Abstract means we can't implement them on their own, and then public means that other classes can see them. Interface attributes are by default public, static, and final. So that means that they can't be changed if we define them there. So also, an interface can't contain a constructor. So the reason why that is because a constructor is used to create objects. And because it can't be implemented on its own as an object, it can't contain a constructor to build one. So why do we even bother? Why use this interface? It seems kind of trivial to define something with a bunch of methods and we have no details in there. Well, it helps to achieve a security. We can specify that we have an animal and pig derives from animal, but we can hide the details of the object itself. Another one, and this is probably the most important, is remember we had discussed how we can only have one superclass for each subclass. So you can only inherit from one superclass. But with interfaces, we can implement multiple interfaces, and therefore we can inherit from multiple interfaces too. So this is usually why we would use an interface as opposed to. So let me go through an example to kind of illustrate being able to inherit from multiple objects. We have first interface and second interface. So first interface is my method, and then in the second interface we have my other method. Remember, we have to define these in the actual class that implements these. So we have class demo class, and this demo class implements from both first interface and second interface. And notice it's getting it from two different interfaces, which we couldn't do with an abstract class. So remember, we have to override these methods that we've defined in each of these interfaces, which we do, and we just print out some text and some other text. And then down below is our main. We put that in a separate class. And all we're doing is, first of all, we create a demo class. The second thing is we actually call each of those methods. So if I run this, and the output is some text and some other text. So we were able to inherit from multiple interfaces. And this is important as you become more advanced in Java, because there are times when you'll need to get methods from different sources when you create an object. So when we implement from multiple interfaces, we separate with a comma. So going back to our example, you can see here when we implement demo class, we implement and then we add commas here. If we tried to do this with two different abstract classes, we'd get an error. So just as a summary of the difference between abstract class and interface, the keyword we use is different. Now remember, with interface, we can only have static variables, whereas with abstract, we can have static and non-static. Access modifiers, remember what access modifiers are. They're the get and set. With abstract classes, we have no restrictions, whereas with interface, we can only have public. The speed, how fast they run, with abstract classes, they're much faster. And the reason for that is because of not having to worry about doing derivations from multiple interfaces. And then when would you want to use it? Well, with abstract classes, we want to avoid independence. So we want to basically not create a class that doesn't have any methods it borrows from a parent class. We want to make sure that the methods that we've created in the parent class, so for example, remember with generic item and we had perishable item, we want to make sure that the weight, the height, maybe a UPC code, those are all in the generic item, and we don't redefine those methods because we're going to use them for other classes that or objects that we create. So interfaces are used for future enhancement and also for the reasons we talked about on the earlier slide, for security and also for multiple inheritance.